In Chapter 11, we also expanded not only upon our construction of confidence interval formulas, but we also expanded upon our sample size formulas. Now we ran into two more sample size formulas. Let me remind you about the sample size formulas we already knew from Chapter 9. So in Chapter 9 we learned three formulas, two for a proportion, a single proportion, and then one for a single mean. So how large a sample do we need in order to estimate a single proportion if we have a prior estimate? How large a sample do we need to estimate a single proportion if we do not have a prior estimate? And then in 9.2 it was how large a sample do we need to estimate a mean? Right, so if that was Chapter 9, in Chapter 11 it's the same idea, except you're trying to estimate how large a sample you need to estimate the difference in two proportions. Example, to estimate the difference in two proportions. And of course, proportions and percents are going to be mentioned. And you're going to see two old percentages from some previous study given to you if you're going to use this formula here on the left. You'll need a P1 hat and a P2 hat from some old study given to you. So if you see some old percentages flying around in the problem, there have to be a couple of them and they have to relate to the data set. Be about your same groups but back in the past, then that is this formula on the left, which is huge, of course, but it's actually not as bad as you might think. It's just, it looks worse than it is. Now the one on the right is you have no old percentages given. You're still asked to ask how many or how large a sample must be used to estimate the difference in proportions. So if you see how many questions or how large a sample questions to estimate the difference in two proportions or estimate the difference in proportions, but no old percentages are given, then that's the one on the right. At this point, I want to make a little quick warning to you. It's the same warning I made in Chapter 9. Which is that you have to be very careful not to mess your confidence level in with your proportions. A confidence level is going to be a proportion. It's usually like 90%, 95%, something like that. But it is not the p-hats and it's not the p-values. So you've got to be very careful not to mess with it and throw it into the middle of your formulas. So keep your confidence level separate. Your confidence level only helps you find your z alpha over 2's, which is your critical value piece right here. That's all the confidence level is good for in these types of problems. It helps you find your critical values for both the confidence interval and for the sample size question. The alpha is determined from your confidence level. That's it. Right? Confidence level does not get used for any of the other pieces and parts of either these formulas right here for sample size, nor for this formula that's not even given to you, but it would not be used there either. Right? It does not get used for that. It only is used to determine alpha for confidence level and for sample size problems. Now, what parameter are we estimating here? Well, you'd be estimating the difference in two proportions, so P1 minus P2. In other words, you're trying to determine if there's a difference in the population proportions for two separate groups, for two independent groups. There we go. All right, so there's that. Now, and that's true for both of them, in fact. It's not just true for one of them, it's true for both of them. They're both trying to figure out whether there's a difference. It's just a question of how many people do you need to poll to determine whether there is a difference or not. All right, now the error, remember, error must be a decimal for proportion problems. It has to be. So it has to be turned from a percent, if it's given to you as a percentage, into a decimal. If it's already a decimal, then you're fine. Right here. We ran into that in Chapter 9 as well. Let me pull up Chapter 9 real quick. So we already ran into that the error must be in decimal form for the proportion ones. The only exception to that is the mean formula from 9.2. That does not have to be in a decimal. The error can be any number you like. But for the proportion ones, it must be in a decimal because your proportions are limited, and the difference in proportions is also limited to between two numbers, between 0 and 1. So therefore, your error must be also limited between 0 and 1. So you have to turn it into a decimal. Obviously, both of these are using the z-distribution as their probability distribution to construct the interval or to construct the sample size, and that means that you're going to use inverse norm or the bottom row of your T table has a few of the most commonly used, if you recall, a few of those commonly used z-scores. So I got to scroll up to this. There we have it. So this is the T table. On the bottom row, you can see there's 12 of the most commonly used z-scores. If it's not amongst those 12, then you're going to have to use inverse norm, left tail area 0 and 1.